Ron's going to be presenting 7 slides with 7 bullet points. And we are talking about, Jason, I'll hand it over to you, because our frame has changed a bit for today.
Yeah, because I expect several all people from the last session will show up, but they didn't. But anyway, we do the recording, so post on YouTube, so people can view them later and get into touch each other later as well. So we'll just go ahead and do it. We have 4 people here already, no problem.
Jason, can I just add one more thing?
Please.
These conversations go really complex very fast. So I just want to invite any people listening after the fact or right now to sort of let it wash over you and just sort of trust your inner knowing. We were just earlier talking about mind, body, wisdom. So just welcoming your brain and your soma to just play a little bit.
Sure. We are pretty open here. Please go ahead, Rem.
Okay. I'll start sharing. 1 second. Okay.
Yeah, we see the cover page now.
Can you see this now?
Yeah, human brain evolved.
Okay. I have actually a couple more than 7 slides, but I probably may not come. I don't intend to dwell on most of them. But, I prepared this to be consistent with the other 3 speakers. It deals more with systems architecture and cybernetics focused. But what I want to say is the human brain evolved naturally as an interface between body, mind, and society. I call this architecture as the open system. And what I want to say is, if you think of brain not just as a physical organ inside our head, but think of brain as a black box that enables communication and control, which is the cybernetics concept, then the same architecture actually defines democracy too. That is really where I want to lead this, to say, by studying brain, we can understand how democracy evolved as a communication and control system for the whole society of people. That's the synopsis of what I want to cover. Okay, I like to be called Ram. I'm currently working as a research affiliate in SUR Lab, which is the Simon Center for Social Brain at MIT. And the three ideas that I focus on is, first is you have to really study evolution if you want to understand biology and how biological systems work. And then the second thing is there is a lot of data, a lot of experiments that have been done and modeling that have been done. But my focus is on trying to discover new ways about thinking about them. And the last interesting thing is cybernetics. I understand it as explained by Norbert Weiner, is it is really focused on an information process where information is neither matter nor energy. Okay. I worked in the magnetic recording head technology, integrating the heads into hard drive storage systems, which is a multidisciplinary system. And that's what has made me into a systems scientist. And I'm currently at MIT. And I was discussing with Jason about this session on defining democracy. And we were talking about how in ancient governance style, there was this idea of sense and act locally and cognize and think globally. Actually, people usually say think globally and act locally. I think consider that as only one part, that is the reaction. But what triggers the reaction is the initial sensation. And that is, you need to sense locally and cognize globally. And then the cognition becomes memory. And when the memory is evoked, that becomes thought, and the thought becomes action. But what is important is there is a local aspect and there is a global aspect. This combination requires communication and control, and that is what all this open system concept is about. I'm writing a large manuscript on the work that I've been doing on the brain architecture, and I'll just share a few excerpts from this manuscript. These are not going to be, my slides are not in bullet format, a little more verbose. The reason is, if anybody who reads these slides should be able to understand the gist of what I'm speaking. If it is just bullets, it's hard to understand the whole talk. So the slides are more verbose than I would have liked to, but I want to try to make it self-contained. So the 4 key points are: brain, think of it as a black box behind individual and collective human behavior. And this actually evolved naturally from primordial beings, from a single cell structure to today's human beings. The brain has been constantly evolving. And the architecture is, it does concurrent processing. It is a scale invariant processing. And it's the way it works is many to many mapping of these 4 things, which is action, thought, cognition, and sensation. These 4, think of it like the 4 elements, the basis of the mapping. And this is being done at multiple scales and time within this brain. And this brain is an open system. It is dynamic, which means it is constantly acting. It is recursive, which means from a very small level up to the organism level to the society level, it is really recursive. What happens at a small level is the same process that happens at a higher level. But most important, in order for that to happen, it needs to be self-organized. And that is the key point that I will focus on. And the other aspect is, in the open system, there are 2 complementary entities. In other words, it is not like one central thing that is doing a transformation of input to output, but it is really 2 things that are being subjected to external influences, and how these 2 things communicate and control between each other. And that is the complementary aspect. And how this control communication self-organizes is the focus of the discussion. These are actually the theories proposed by pioneers of the cybernetics, like Norbert Wiener and Ashby and Stafford Beer and others. And interestingly, if you read their books on this cybernetics, which is the communication control, actually were modeled after the brain architecture. And I've come from the reverse side, starting from the reverse architecture. Now I'm trying to understand how this, the topic of cybernetics is actually the same idea, but applied to generic systems as opposed to just the individual organism. So we can start with Ashby's law of requisite varieties, when actually in his book, what he says is that the organism is mechanistic in nature. That means it's composed of small parts, and the whole is the sum of all this compounded action of the parts. And the organisms change their behavior by learning. So in other words, it is a recursive system. It learns the behavior, facilitates the change by learning. And every time it changes, the later behavior is better adapted to its environment than the earlier behavior. So he says the goal of the design for brain is to try to understand how the nature of change shows up as learning, which I'll talk about, and why does learning make the organism better adapted than it was before. Interestingly, the same concept, instead of an organism, if it's applied to an organization, which Stafford Beard called as viable state model, this work was also derived by studying the architecture of the brain and the nervous system. So this is the drawing that you see in Ashby's book. The key part here, what it says is, here is the disturbances or signals coming from the outside, and here is the action, which it calls it the essential variables. And there is a normal transformation process that happens, but in a control system, there is also a regulator. So this is the cybernetics model, but you can also think of it in a different way. The disturbance is the sensation that is coming into an organism, and the essential variable is the action that the organism takes. And the organism itself is composed of a body and a mind. But how does the body and mind work together is through this brain. Instead of, and in a general case, the brain can be considered as a black box. So it is this black box that facilitates the communication between the regulator and the transformer, and it establishes links between sensations and actions. And he calls it varieties. You can call it signals, disturbances, lots of different names, depending on the field that you come from. There are so many different terminologies, that's the reason why it is difficult to understand a lot of these things, is because there is no unique terminologies. In every field, people give it different names. But the basic idea is, it's a system where it is actually open. You don't know where the disturbances are coming from and what your actions are going to lead to. This is just the body and mind is subjected to outside influences. Okay, and the body and mind are working together through brain, and I'm going to say that the brain itself needs to be compartmentalized to your body side and your mind side. I'll discuss that.
I'm sorry to interrupt. I'm sorry to interrupt.
Yeah.
Jason, can you please check the chat? Would you please check the chat? Thank you.
Okay.
Sorry to interrupt. Thanks.
Remy?
Just
yes. Go ahead. That's fine, Ram.
Please continue.
Thank you.
Sorry.
Yeah. Lisa, I'm not sure what your expectations for today's discussions were. I was really focused on responding to Robin and Slavo and others.
No. It's just a matter of co-hosting that I'm asking. It has nothing to do with your presentation. It's great. Thank you.
Oh, okay.
But can I ask, since you're the only presenter, can I ask you to slow down a bit?
Oh, okay.
Thank you.
Okay.
We have time, no problem.
Since it's a small group, we don't have to keep it formal. So if you have any questions, please ask me, interrupt me, so that because that's what makes it more interesting discussions. I'm open to discussion. So in the previous slide, I showed Ashby's model talking about a regulator, and then this is the communication, the transmission side, and then there are external influences coming from outside. I'm saying that the same thing happens in the individual self. We have a body that has a sensation and that is capable of action, and it also has the brain part of it that gives it the awareness. And similarly, on the other side, the regulator, which actually takes a lot of the learning and makes it into a memory bank and uses that to regulate the processing of the sensation. So this regulator, his job is to make meaning out of the sensation, which we call cognition. Cognition is the creating meaning between the sensations and action. And when the memories, cognition is stored as memories, and when the memories are evoked, that becomes thoughts. And the mind, in order to keep the behavior going, it needs to pay attention. So there is an immediate awareness from the body for the external, due to the external sensation, and the mind produces attention, which keeps it sustained on the behavior. So this is at the individual organism level. But if you go a level above, in the beautiful thing about the human beings is we develop the symbolic language. That means we don't really need to be physically seeing and doing things. We can just mentally create the whole sensation action, emulate it using symbolic language, and we can communicate across the fellow human beings. And that leads to a lot of complex behaviors over longer time scales. And then this individual organism now actually becomes a collective organism, which we call it as a human society. And in our center, we call this as the social brain. So in other words, the brain itself can be broken into three parts: the perceptive domain, which deals with the instantaneous sensory motor reflexes; a cognitive or a knowledge domain, which has the memorized representation of all the past learnings, and it allows us to recall from the learning and use that to control our behavior. And then if you add social values, then it becomes a social brain, and then we can communicate across peoples, and you are able to communicate using symbolic language. And this is what the Homo sapiens, very high level in the whole kingdom of natural species that are alive today. So I call this model as the dynamic, recursive, self-organized ensembles of complementary dualities. The complementary duality being body and mind, sensation versus action, awareness versus attention. There are all kinds of dualities. I break that down into what is a discrete one and a continuous one. You can call this as observation and deduction. So in my manuscript, there is, I go into a lot of details, and I'm just using a lot of words here, and hopefully I'm not confusing you too much. So I'm saying the model of the organism is I am body and mind in this world at this instant, and I consciously experience and think. This is the structure and this is the function. So this is the gist of my work. Now the question is, it was very well posed by Stephen Grossberg. He wrote a book called Conscious Mind, Resonant Brain in 2021. He asked the question, why should it be plausible that conclusions about the brain may have possible analogs in economics and politics and in general? Why is there so much commonality? This is what I'm talking about today. So he uses this concept of sigmoidal function. What it says is, what he's talking about is this sigmoidal signal, which is ubiquitous or very commonplace in the brain, resembles also the key features essential for a hybrid governance system. In other words, the sigmoid consists of three parts: a faster than linear part, a linear part, and a slower than linear part. And these three phases resemble moments of totalitarianism. That means a small group of people move very quickly and come up with for a given change that is expected or a given disturbance. They identify what is the signal part of it, what is the noise part of it. They come to a quick understanding here that is called the noise suppression and contrast enhancement, or the quick things. And this is a small group of people. And then a large group of people then take that signal and work on it and apply it to the whole society. It's a roughly linear type of change. And then once that change has been accepted by most of the people, then there will always be some people who would not have caught up to it, and you need to go through slowly and get to it. So the governance can be thought of as a hybrid system. It's like moments of totalitarianism, but this is a winner takes all philosophy. And this is what actually happens in the brain too. A few groups of neurons very quickly discern what out of all the incoming data, what is a useful signal, and it tells you, oh, this is what I'm seeing or hearing or I'm touching. But from there, you need to really take those categorized features and try to consolidate them into an object that we can understand. And in this case, in the case of government, you can try to move a lot of different people towards a new change. But then you cannot leave out those who are slow. And this part is what, this center part is what people typically think of as democracy. And then the third part is socialism. That means making it all equitable and making sure that everybody is brought on board towards a new change. So, Jason, this is what sort of roughly discussed. And I think you had it in your call for discussions. You were discussing something like this, right?
Very interesting. Would the last stage still become a little bit totalitarianism? Like everybody start having to obey the same rules, like the vaccine injection, for example.
Right.
I mean, I just threw in some wide example.
Yeah, that is where the key thing is. The democracy has to be participatory. You have to get the buy-in from all those, and those who do not. Sometimes there'll always be exceptions, right? So actually, the sigmoid is a cumulative distribution, which is an integral of a normal Gaussian distribution, right? This sigmoid comes from integrating a normal distribution.
So this is definitely relevant to the bell curve, right? In statistics.
Yeah.
You agree?
Okay. That is, if you think of people as it is basically a large collection, it's a statistical ensemble. And when you want to switch a statistical ensemble, what nature does is it creates this kind of architecture, and that's really what I'm trying to explain. That your select group makes a quick, it discerns order out of chaos, it discerns signal out of noise, or figure ground separation, or noise separation, content, whatever you want to call it. There's a small part that quickly makes some sense. And that is the body-brain portion of it, and I'll discuss it in the next slide. And then out of if you just immediately respond to it, this becomes more like an emotional judgment, or totally it becomes authoritarianism, and in which case there is no participation at all. So you have to use this as a guide to say, okay, here are all the things that need to be concerned. And a much larger body of people then go through that, the change discussion, and say, oh, what are the different features that have been recognized? What do we need to keep? How do we put this together into an assembled idea or a policy or an object? And then how do we then integrate it into the whole society here?
So you see this as a universal transition pattern between an old order versus the newer order. Can I interpret that?
That's right. So this is like a state change going from A to B, from an old order to a new order. How do we do change management? So you can think of governance as actually a change management, but I also think of change as evolution.
Yeah, and this happens again and again, recursive.
Right. So if you put up, that is the whole idea is nature already gives us some guidelines on how it manages the evolution, how it manages changes. And I'm trying to say, even in the case of the governance, if you go back to for example, I was talking about in the ancient society, people started with like tribes, and they had local actions and local sensations, and they were doing. But as the society started to evolve into bigger and bigger groups, they had to have some global things. That is, now from a family, you became a tribe. From there, it became into like a village, and then you need to protect yourself from the neighboring village, and you have to have certain defense systems and other things. And so you need like a global thinking, but global thinking cannot be immediately imposed on all the people here. The change has to happen in a certain ordered fashion, a fast phase and a steady linear phase, and then a slow phase. Some people see this is an asymptotic curve. You don't expect it to reach 100%. So some will never change, right? So that is the idea. So you try to go towards a socialistic idea, starting with a totalitarian. If you let these authoritarians take over, then you don't have any democracy. And if you make it all purely democracy, then you will just be swamped by noise. Every little thing people will start debating. So pure democracy or pure participation alone by a large number of people also doesn't get you anywhere. So you need this three-phase thing. And I was looking at Slava's viable state model that he presented. It was interesting. He had three phases here that he talked about: market, hierarchical, and network. And he was saying that that leads to a strength, effectiveness, and inclusion. What the market, I think of it, is this fast response. Market response is typically considered fast response, right? So fast response gives you the strength, but making sure that it is done in an orderly fashion, taking the time to do it correctly, that makes it effectiveness, but then not leaving out any part of it and getting the whole organization or whole firm or the whole society to change, that is inclusion. So this also looks to me like the same three-phase idea concept. So unfortunately, people think of democracy as only the center part. But if you generalize the concept of democracy as participation from the whole community, then you realize that the whole community is not a monolithic system. You can't make them all change instantly at the drop of a hat. It takes time. And this is the change management. How did nature do it? And we are saying that the nature does it in this sigmoidal fashion: fast, steady, and slow. Okay, this is really my definition of here democracy as derived from understanding the brain architecture. Okay, the rest of the slides are really on systems approach and on the concept of open system. I won't belabor into these things. So what I'm trying to say is open system is a self-organizing entity, and it consists of three parts. This is actually David Marr's ideas too. That is, you have an implementation, and then an algorithm, and you have a theory, which is same as architecture, and then a structure is the physical hardware, and this is the methodology, is the how do you define the input output, and how do you have the algorithm that maps the together. And key thing is, on closed systems, it is very easy to define, and most of the science is geared towards applying this model to closed system, but it doesn't work in biological systems because the biological system is constantly self-organizing. It only is embedded with an architecture, and the structure and function are fluid, constantly changing, and also the structure and function become complementary entities. The structure drives the function, and the function makes changes to the structure. So this is actually, if you think of it as a Darwinian things, what he says is natural selection leads to mutations and adaptations, but we can make it more rigorous and say that the self-organization leads to structural changes or structural mutations. And functional adaptations, which is the methodological changes. So this is, in essence, a Darwinian concept, but more rigorously stated in systems terminology. And I said, okay, if you apply it in individual, we have now body, mind, and brain, and that defines the self. And within the brain here, so this is, you can see, it's kind of recursive discussion here, going from self-organization to self and going into self as brain, and brain, defining the brain itself is actually sensations and actions. This is what Ashby calls as requisite varieties. That is, if you're going to have a regulator, the regulator need to have in its repertoire a full list of actions that it can map to a full list of sensations. So this brain then becomes a mapping system, and the mapping system needs to have a memory. And the memory in this case is a sequence of reflexes, and the reflex itself is defined as a combination of sensation action. Okay. So then you can take it further into say, what is memory? And the memory is physical reflexes, or what William James calls as cerebral reflexes. And actually even Ashby refers to it as the reflexes here. And now I'll skip this part on consciousness. That will get into debates.
Oh, please don't skip.
Oh, you want this guy?
Well,
okay. Oh, this
I want to back up for just a second and just
Yeah.
make sure I understand requisite variety and why it's called that.
Okay. Oh, the variety in general means just an elements of a set. And in this case, I can say variety is just a list of sensations. And another variety is a list of actions. So in a cybernetic system, when they say requisite variety is being mapped, we are really mapping sensations into actions. So the cybernetics is the concept of how a system behavior is characterized. Okay. In our case, so if the self is made up of body and mind, right? Mind itself, normally you cannot see it. And the way I define mind is actually it is a portion of my brain that is hidden inside a portion of my cerebral cortex. It is all the memories that I have and how I use the memories. That portion, if you think of it as an independent organ, it is residing in my body, but it is separated by the blood-brain barrier and it is hiding somewhere. It's doing its own things. And we can give it a name, we can call it a mind. So I myself is body with all the external organs, and I have the mind inside. It is hidden, and the mind is being trained by the body organs by means of sensations and actions. And what the mind is doing is it's creating this large database of collections of sensations and actions. Now, when I say action, it doesn't mean just physical action. When you see this screen right now, you're taking the screen and breaking it into different parts and then focusing on different sections. Now, what does that mean? If I say breaking it and focusing, breaking is an action, focusing is an action, but that is done by the mental portion of your brain, the mental cortex. It says out of all these pixels of energy that is coming from my eye, there are certain pixels that I'm going to put together. I'm going to call it a certain feature. In this case, out of all the things that I see in this room, here is the screen, within the screen, here is the slide, within the slide, here is a zoomed portion of it. But in order to be able to zoom into that, my eye has to be panning, it has to be focusing, it needs to be zooming. All of those things are controlled by motor muscles, oculomotor muscles inside my eye. So those actions are controlled by my mind, mental portion of the cortex. So the self is consisting of body and mind. And the brain, in this case, brain and mind are actually, it's synonyms, but you really have to separate a portion of the brain into a separate organ. A portion of the brain is connected to the body, a portion of the brain is connected to the mind. So if you ignore the brain, then we really have, myself is made up of two distinct entities. One is body, the other is the mind. Do you follow me? No?
Yes, I do. And so this gets to that Cartesian split in Western science and colonialism, where, Descartes, I think, therefore I am, and it pushes so much value on mental and linear processes. So where Gail and I are curious is, so what becomes salient is where we are first directed, and the brain learns, for survival's sake, to notice threat. And we have this negative aspect. So I want to, bring the point about humans respond to threats of trauma, and how the model that we're in now, especially, you're pointing out how democracy is still young. If you consider Earth time and evolutionary process, this is still very much an experiment,
right?
And depends on communication. And we're stuck in a language, mostly globally English, that has the subject-object focus rather than verbs, which express environment. So the effects of trauma and racism, I'm curious, like, how this weaves into not only what becomes salient, but the stories we tell ourselves and each other, which get amplified. Right now, there is a lot of signal and a lot of noise.
Let me add a little bit here.
Yeah.
Ram, your work, this triangle work, is very similar to my own work on that four-dimensional system thinking frame.
Okay.
But instead of structure, function, and architecture, I use structure, procedure, and culture, which the cultural dimension will address Lisa's.
I'm sorry, what's the word again? I missed it.
The structure, like politics, institution, and procedure.
Yes.
Procedure is kind of a combination of your function here, but it's both energy and information processes. It's procedure.
Yeah.
What's going on at the micro level of the complex system. But the third dimension is like it's like there's a chemical soap in the brain, the cultural part. The cultural part is consists of a slow process of people's emotions, feelings, and people's beliefs. And you see, emotion, feeling, belief, they are not procedure, they are not structure as well. So it's just kind of a soap, a pot of a soap there that the ingredients change slowly on the time. So there's a different framework of triangle, but we can discuss next time. But that hopefully will help Lisa's perspective, focusing on those what you call the feelings part, the emotional part.
Right. Actually, I was going to tell Lisa that no, this is not the same as the I think I am model, because that only talks about the mental portion of it. I put a lot of emphasis on the body side of it, because originally, if you think about it, all primordial beings started out with just bodies and just straight reflexes. Okay. And even today, as in human beings, our goal is to make a lot of this memory knowledge into simple procedures that we can kind of offload into body. And actually, if you look at the architecture of it, right from the prefrontal cortex, cerebellum, and the basal ganglia, that loop itself, you can take care of a lot of activities. So in fact, I would say almost most of the day, I'm really working with just body and the body-brain portion of it, and not really involving much mind at all. So the self is not just mind. Self is predominantly body and the body-brain. And the goal is to automate it as much as possible and make it a involuntary process itself. And then the mind is constantly thinking about higher and higher order impactful things. Okay.
Okay. Please continue.
So, yeah. So, okay. Now, actually, this slide I had used, I had recently given a presentation on consciousness. There is a lot of debate amongst the scientists about whether consciousness has a material substrate or is it simply a neural network. So what I'm trying to say is consciousness is a noun, whereas when you use the word conscious, it is actually an adjective used to describe the state or matter, material states, whereas the word consciously is an adverb, and that is used to describe actions, voluntary actions that we execute. Now, unfortunately, people use all these three terms they mix it up. And that is why we have so much confusion in terms of defining consciousness. So what I'm saying is, based on how the brain works, the sensation causes changes in the state of the body. Okay, so that is that conscious state change. If when it is happening in the body, we call it awareness that is produced by certain neuromodulators. And then when it is the conscious state of the mind is changed, and that we call it as attention, that is caused by two other different neuromodulators like dopamine. And so this conscious state change, people think of it as consciousness. I don't think so. This is just a material state, conscious state. And then when we say consciously executing, so for a given sensation, we make a decision as to how to respond to it. Or when a thought is evoked from our memory, we decide how to execute it. And that is when we voluntarily do it. Volitional action is the consciously performed activity. And that here it is an adverb. So then what is consciousness? I'm saying consciousness is a noun. It is an information process. Okay, it ties how it relates the change in conscious states to the consciously executed actions. So when a state changes in the body, it becomes an action. Or conversely, when an action is executed, the sensory states change. And this relationship is the consciousness. This the repository of all these things, and how we are then we use this consciousness to control our behavior. So this is neither matter nor energy, and that kind of takes us back to Norbert Wiener's definition. Information is information. It is neither matter, it is neither this matter nor it is energy. It is information here. So this is how I presented in a recent conference on consciousness. Okay, so kind of, I think we discussed a lot of these things already. The human brain is also an open system. And the past experiences of such a self-organized functional being then become its inherited and learned memory, and this knowledge guides behavior. And this whole process of how the past experience governs the behavior of the organism, this This is what I think of it as the core of human consciousness. Now, how this whole thing come about, that is a natural evolution. So I think we can go through. So mathematically, how do we define self-organization? And this is where I get into a lot of statistics and matrix algebra and all those other things. But if you want to phrase it in simple English, the self-organization consists of two distinct processes. One is a fast, discrete, long-range selective release of suppression, or you can call it a selective excitation. And then the other one is the slow, continuous, local, and broad suppression. That is, this is external influence coming in. This is the internal state of the system. So this is discrete, this is continuous. And this is the complementarity. And this complementarity is the self-organization process. And it is typically recursive, fractal. And this process is repeated over multiple spatial time scales. And the beautiful thing about it is, since this system grows in size by the repetition of the same process, there is no complexity with scales. So whatever happens at a very elementary tubular level inside your cell, or what happens inside your neuron, or what happens in a neuronal column, or a nucleus of a brain, or the whole brain, or what happens in your body-mind system into society, everything is all the same thing. And this is what we are saying. I said earlier, think globally and act locally. So you can see here, this is local action and this is long range action. This is thinking globally and act locally. If you understand that one concept, think globally, act locally, we understand evolution. Now, thinking and action alone is, if you talk about it, then we get to the original discussion. I think I am, that only talks about mind. But there is, mind alone is really like a mushroom that is hidden inside your brain, and it has no real outer world contact at all. All the outer world contact comes through your body. And so it is not just think globally, act locally, but you also need to sense locally and cognize globally. That is, whatever I sensed, how does it impact? What does it mean in the big scheme of things? And so you need the four parts, the ATCS: action, thought, cognition, and sensation.
Ram, could you please say a little bit more about your term suppression here? Give us some specific examples. Suppression, first phase, you do the release, the left, and then you broaden it. So what exactly does that mean?
Oh, okay. So when you go back to the sigmoidal curve that I was talking about, so in the initial phase of the sigmoid, the activity is happening at a very fast scale. In fact, it's an exponential growth, right?
So it it's kind fast. Of a pressure, you mean?
Pardon?
A kind of a pressure generated by the leaders.
Yeah. See, in the case of brain, this is called inhibition, right? It is a chemical inhibition. It's a chemical that is applied to prevent the neuron from firing.
Oh, okay.
Okay. So suppression is inhibition, and excitation is the opposite of inhibition. Now, what I mean by selective release or suppression is, most of the time, most of the brain needs to be inhibited. Otherwise, you'll have billions and billions of neurons firing all the time, and that is called epilepsy. Your brain will be in a constant state of epileptic state. You don't want that. So most of the brain is kept in an inhibited state. And you need to selectively release certain sections. So if you think of brain as a gigantic network, most of the network is dark, and you need to now shine some light or pass some photons, or in this case for the sodium and potassium ions, through certain pipes to activate certain neurons. So you want to selectively activate only a portion of the network. So the selective release of suppression or selective activation comes from long range, which is the part thinking globally. And it happens as a discrete activity because into the neuron, there are lots of dendrites, and some of the dendrites are getting input from some other neurons elsewhere. So that is the part globally. It comes in fast, and it comes in some discrete input. Actually, mathematically, this is a Poisson process. Okay. And then
thank you.
Inside the neuron, you have slow continuous, because inside the neuron, there is a lot of chemistry, biochemistry that is going on. Receptors are opening, genes are being expressed into proteins, and proteins are the receptors, and that are letting in the chemicals to come in through. So this is a slow continuous process. So this process beats against this. So this slow continuous process is actually an exponential process in terms of statistics. So this is an exponential distribution or exponential process. This is a Poisson process. And the beating of this against this together constitutes a sudden emergence. When the two of these collude together and reach a certain critical threshold, that's the avalanche, at that point, a spike is generated. So all activities are avalanche processes enabled by the Poisson process and the exponential process at criticality. And that is where this whole idea of criticality and chaos and all those control, all those theories come in. So you can see that from a very simple idea, think globally, act locally, you can just build it into an enormous complex mathematical statistical ideas here. That is what I've been working on. No, the interesting thing about, yeah, go ahead.
I want to make sure I'm understanding. You're using the term Poisson process?
Poisson. I'm sorry, my pronunciation is bad. You go ahead.
Can you spell it for me?
Poisson, Poisson. That's a French.
Oh, Poisson.
Poisson. Oh, Poisson.
And what does that mean? Sorry, one of my majors was French, actually.
Can you repeat that again? Let me try to repeat it.
Poisson.
Poisson. Yeah.
Poisson.
I know.
Means fish.
I know. I learned it. I learned it bad, and I'm not able to get it out. Poisson. Yeah.
And why is it named that?
Huh?
It's a name. It's a name of the statistician.
Okay. So what is the Poisson process?
And see, in a continuous process, there is the change that is, for example, if you think about radioactivity, inside an atom, there is a lot of energy constantly coming out. See, that is a continuous process. Mathematically, that is modeled as an exponential change, okay? So that is this second part here, slow continuous. This is something like a radioactivity. Whereas this one, the Poisson process is like you're sitting in a hotel or a restaurant, and there are people coming in at random times. So that kind of random activity is called as a Poisson distribution, because you cannot a priori say how many people are going to come at a certain time. So one of the examples they gave is like if you're sitting in a restaurant and then suddenly a bus comes and a lot of people come in, there is a lot of activity. And then the next 20 minutes, nobody shows up. So that kind of distribution is called the Poisson distribution. And what I'm saying is in an open system like myself or a society, you don't really know what is going to happen on a regular basis. The impact can come suddenly. It can come in large quantities, small quantities. It can come from very diverse spatial distributions, diverse temporal distribution. But there is a mathematical equation that can be used to model even that kind of process, and that equation is the Poisson distribution. So this is what I'm calling as global thinking. Global thinking means you expect the unexpected to happen at some point. Whereas this one is constantly doing something inside me. I can't just sit and wait for something to happen. I need to be doing something ongoing. My ongoing activity is this. This is the exponential part. And the unexpected part is this. So so natural evolution needs to be able to respond to both of this. And how did nature come up with the architecture to enable us to do this? And that is what is the talk is about. That is what I call as an open system enabled by a natural evolution process. And this process is what I'm calling is think globally, act locally, but mathematically more involved. Okay?
Okay, go ahead.
No, see, if you're most of the science, people just take a little box and say, oh, inside this box, there is something that is some generating energy, or there are boundary conditions, heat cannot escape outside or close adiabatic condition, or the external condition is kept at an isotropic temperature, those kind of things. That is the science. All those equations, the so-called laws of nature that we have derived are the equations. Those are beautiful. They work as long as it is a closed system, but they cannot work when you're talking about a evolutionary process where there are no boundaries in space and time. The boundary and initial conditions are not known. The mass and momentum are not necessarily conserved. And the most important thing is there is no equilibrium that is within any subsection. And this is the definition of an open system. How do we model this? And that is what the brain enables us to do, to respond to these kind of open system. So in this case, for the brain, there is no supervisor or agent governing the interaction between this input-output, and the process is self-organized. And the key aspect of this process is the cause is not one or the other. The sensation is not always, sensation causes action, but action also causes sensation. So it is, the process is going both ways. It is really the relationship, configuration of relations, and it's a circular relation. It is called synergetic by Hermann Haken, or it's called reciprocal by Georgi Bisarki in NYU. And this kind of system is what we are talking about when we are talking about governance or democracy or relationships. And in this relationship, there is simultaneous actions of both cooperation and competition. So when we are dealing with people, you can see in general, people want to cooperate, but when it comes to vested interest, then they start to compete. So there is always constant cooperation and competition between two types of systems. And while the parts do cause the behavior of the whole, the behavior also constrains the behavior of its parts according to majority rule. And this is the basis of open system architecture. Oops. So I'm saying that the human brain is also an open system. Now, this is where I want to generalize and want to say, when I say an open system, it doesn't mean just your body, just the mind, or just an individual, or just the family or the society. It can be the whole species. And you can go all the way from quantum scale to cosmic scale. Everything is an open system. And when they say brain, it doesn't mean just the organic brain that is inside my skull. It is actually referring to your black box, which channels communication and control between these complementary elements that I'm talking about here, complementary elements of this open system. And what it needs, the communication control needs to be channeled in a context-relevant manner, and it needs to assign appropriate salience and valence for this activity. And this is the job of the black box. So in myself, the brain is doing that kind of work. And in a society, the individuals are doing that work. And in the whole species, different societies, different countries are working together as a human species interacting. But the key thing is the process is the same. That's the gist. Okay, I won't go into this.
Can we pause for just a second?
Yeah.
I really appreciate how deeply you dived into this. And I'm just like that last point, I feel like there's a bit of a jump that I'm hoping to understand, is that when you talk about democracies or governmental processes and the individual's interaction, so we're talking about structures and processes, but the fact that the structures are experienced so differently in terms of the processes and their effect on the individual. So I'm coming back to the point about the environment that is different. So the lens that I'm looking at is, say, a community garden project in a part of a very segregated city, where the land was carved up by a freeway system that created institutional poverty, and racism is a factor here too. So when we talk about the interaction between the individual and the structures in complex adaptive systems that are no longer able to adapt, this is the piece that I want to bridge to understanding governance and democracy and the role of the individual's experience as one that can't really be generalized if we're not including systems of trauma and their effect on the behavior and the stories and the memories.
Right. Yeah, so yeah, I think that's kind of the nice lead into this slide. I think let me see whether I can cover that. So what I'm trying to say is the way the brain enables my activities is by creating memories through learning process, which is what I'm going to say is the answer to your question too. That is, in the brain, the basic message that is traversing is really the sensory motor reflex. That is, for a given sensation, what action did I take, and was it beneficial to my survival? And if it is, then it is stored as a memory, and a sequence of many reflexes becomes the what is called an associative memory. And I'm saying that that is the same idea that you see in Ashby's generalization here. What he calls as the requisite variety is between what he calls as the disturbances and then the what he calls it, the E variables, the essential variables, that relationships has to be learned. Okay, and that learning should become a memory, and it needs to be communicated. So to answer to what you're saying is the process cannot be just written down as a law and passed on, but it has to come from within every level of the organization that is involved in your project. That is starting from the upper echelon to the final most person who is probably working in the garden, to the person who is overseeing the whole garden project. Everybody needs to have very similar value system. And that value system comes from learning.
I think Lisa's pointing out that the different observer with the different stakeholders
right.
from a different angle.
Right.
So actually, she's pointing out outside community groups. It's like the main control group versus the groups being controlled or reluctantly being controlled.
Right.
So that is another interesting situation your model has to deal with.
Right.
I'm not sure if I interpret.
I know.
Yeah, I think that's very helpful because the financial system and the governmental system is still a zero sum, winner take all, winners, losers, power over rather than power with, which is not the values of traditional understanding of community in, say, African traditions or indigenous communities. So I guess that's, and I'm not arguing, I think this is brilliant work from, and I have particular interest because I led a research protocol for folks, older, frail adults and people with living with dementia. So your previous slide about agency and consciousness is really very helpful with this idea of a black box and
Right.
and I'm just sort of troubling the waters a little bit to invite the direct application of the model into community.
Right. So in the model, we are constantly getting all kinds of sensations and we are doing all kinds of actions. But everything that we do is not really stored as memory. Only some of them become reflexes that is for this sensation, I must do this action. What makes that happen? And that is the reward system. Okay, so in the next slide that on how memory is formed, I can probably I'm talking about that. So the key thing here is reward is this manner by which natural evolution figured out how to create memories. And so that is what is called operant conditioning or classic conditioning, or how we create memories. I guess maybe it is right here. That's the next portion. The operant conditioning and classic conditioning. What does that mean? That is, operant conditioning means you take a certain action, immediately that leads to a sensation. But based on past experiences, that sensation says, oh, for this sensation, I must do a certain action. And then it just, the chain keeps going. It's like a domino. And that is what we call as memory. But how did this chain build in the first place? It needs to be built by having a reward or a reprimand. Unless there is a reward or a reprimand that is associated with a certain reflex, that reflex will not become part of your memory. So whether when you're dealing with the individuals, you have to, as they say, you have to make them have a skin in the game or have some interest in it, and they should find the activity rewarding. And otherwise, you don't learn, otherwise it doesn't become a learned memory. So reward is the motivator. So to answer your, what I would say is the learning happens only when it is a rewarding experience. Yeah. Everybody has to have a win-win feeling. It may not be very big, but at least at small levels. And in each level of the system that we are looking at, in the rewards initially could be very small to a little bigger like that.
I appreciate that there has to be a certain level of safety for learning to happen. So
yes.
If the affective filter is up,
right.
it won't.
Yeah. Safety is one form of reward. See, one of the primordial emotions that we have is fear, right? So how do you overcome fear? By having a sense of safety. So the safety is the reward that helps us overcome the fear, and whatever activity that gave us the safety then becomes a learned experience. And so the next time when there is that fearful sensation comes in, we act based on this rewarding action. So that is the
government,
evolution.
sometimes government can take away that safety and put a huge fear on you by threatening that they were going to fine you, like $70, $50 per day before you make your compliance, that sort of thing. So,
right.
Right,
Yeah,
right.
no.
And that happens disproportionately in the neighborhood
Right.
that
that happens to our village, actually on me right now.
Yeah.
Yeah, Jason has an interestingly similar case to be considering. It's both talk about the local and the global, right?
Yeah.
Let you finish
Yeah.
your slides.
Okay. I have only, I think,
discussion.
only a couple of more slides. I should be done soon. So let me rush through this. So I'm kind of going back to what you were saying earlier, Jason. That is, when I was talking about the architecture, I'm saying from the brain, when you just now replace that brain with a government, which is the black box, then the procedures and policies developed from past incidences, that is from the interrupts and the responses, become the memory or the rule book of the public administration system. So you can see that the same evolution process plays out in a larger scale in the public administration, and the past incidences become the memories, and that becomes the rule book, and that which is what you are calling as the procedures and policies. Okay. So the interesting thing here, again, the next analogy between the brain and the public administration system is in the neuronal representation of memory, we need what are called neuromodulators. That is, there are many different mappings between sensations and actions, but only certain actions can be associated with certain sensations. What makes that happen is this neuromodulators. And what are neuromodulators? Neuromodulators are the ones that create a body state change, which we call as emotions. Okay, I'll show that in the next slide. But before that, I'll just show the analogy to a public administration system. So just keep that thought in mind, neuromodulators. And the electoral process is analogous to the neuromodulation. So what I'm saying is the public administration system, there are members that are elected at many different spatial and temporal scales. And these elected bodies or nominated bodies that provide the current context and establish the relevance and assign salience to the current happenings. That is, a law that was passed 1,000 years ago may not have any relevance to today. That needs to be changed. And that is why you have new members and new modifications and laws get changed. And this change process by elected or appointed bodies is what I'm saying is the equivalent of neuromodulation. And how does it work here? See, this is the memory model here. See, in brain memory, a sensation triggers the release of a chemical called norepinephrine or adrenaline. Epinephrine, same as adrenaline. It creates adrenaline, and that immediately alerts your body to say there is a stimulus coming in. Then another chemical called acetylcholine is secreted, which says, oh, let me now move my eye to this location, or stop listening to some music and just listen to the news signal that is coming in. This is called orientation. So this is the body part that raises a fast awareness to the oncoming stimulus. Then the mental part of it says, okay, this stimulus coming in is triggering a certain action. And this association was created by release of another chemical called dopamine. And it says, oh, this is an interesting thing, which means the dopamine is creating a positive valence going through a positive circuit. And I'm going to pay attention and keep on listening to it. And this is the execution phase until it is saturated by a release of another chemical called serotonin that says completion of the activity. And this provides closure. So the memory formation goes through this neuromodulatory sequence. These are the basic neuromodulators. And there are other, of course, other chemicals like the oxytocin and neurotensin and lots of other things that we won't get into. But the basic activity of the brain is controlled by these 4 neuromodulators. Okay, and this, but so you can see here, this happens at an extremely fast time scale. This is called gamma period at 25 milliseconds. This happens at a smaller time scale, 65 milliseconds at a beta period. Then the dopamine acts to create initially like up to about like a half a second, and that is what called as free will period, and you get a certain activity here. And but if it is a long procedure, it just keeps on going, and eventually the serotonin says, okay, I'm done. I keep on washing my hand until I feel I'm clean and I'm done. But for some people, that secretion doesn't happen, and it becomes obsessive compulsive disorder kind of thing. So you can see a simple memory formation model can help us to understand even up to disease progressions, but it also shows how the memory is formed. Now,
so
if you
want... NE, what you pronounce it is the one to generate stress and fear. Is that correct?
Yeah, see, NE here is the norepinephrine, but epinephrine is another name for adrenaline. So there is basic adrenaline, there is also noradrenaline. Noradrenaline or norepinephrine, it's the same chemical given 2 names, norepinephrine and noradrenaline. This is what typically neuroscientists use, but I could have called it noradrenaline. It's adrenaline rush. It's sudden sensation. You heard a loud sound. There's a little adrenaline that comes in and you jump, right? So this is the quick response that you're seeing, and that is this part. Then you need to get some details to say, is it really worth worrying about? Is it just a bird flying through my window, or is it a bullet coming through my window? Should I dodge, or should I just ignore, right? Those kind of things. So this is the body awareness. This is the fast process, and this is the emotion part of it that happens. And this is the logical part of our brain, which is the mental part of it. This is the emotional part of it. This is the body brain. This is coming through the brainstem and the lower brain and the right up to the midbrain portion of it. And this is what is happening in the knowledge domain on the upper portion of the brains.
What does Kahneman mean?
Daniel Kahneman and Tversky, they wrote a book called Fast and Slow Brain.
Oh, it's the name.
Okay. So that some people, you can just call it the gut brain or the emotional brain or the quick activity. And so what Kahneman's, I think he got a Nobel Prize for proposing that kind of architecture. That is, he's saying that he talks about the behavior, he's a behavioral scientist. Okay, that is what his Nobel Prize is for.
Ron?
And he...
Oh, sorry. Yeah. Please finish your thought, and then
so I was going to say the same thing now we can apply to a larger body. So you have to have people that are going in the front line taking quick read of what is the change that is coming in. And then some people who will get more clarity to say, is this really of any relevance to my society? And then if it is, then you pass on to another level of organization that is going to do sustained activity. And then some group is going to see whether the results were accomplished. If it is, then that activity is closed. So you can see this same memory formation, short-term memory formation is the same activity process, whether you're looking at a small brain level or a whole society level. These you go through the same phases.
Well, and that's
organization should be set up this way.
That's just where I want to go in terms of society now.
Right.
And so you mentioned earlier epilepsy, which was so interesting. I didn't know about that constant fire. And you mentioned obsessive compulsive. And so I would say societally, we're noticed uptick, or maybe it's just that it's being reported, but of adults diagnosed with ADD or ADHD, right, attention deficit order. But it's a misnomer, because it's actually, for some, it's actually an ability to see the nonlinear and also have hyperfocus. So I'm curious in terms of like that earlier conversation about signal and noise
Yeah.
or trauma, because this is, you know, it's things like hoarding are
Yeah.
signs of a trauma response, but you can't separate it from a capitalist system that says, here, buy this, and then you'll be happy. So I'm just curious if you could connect this perhaps to attention deficit.
Yeah. Right. And actually, this in this model, when the signal came in and they responded, and there is an awareness of the signal. Actually, in the case of autistic children, there is a chemical called parvalbumin that doesn't secrete properly, and they are not able to immediately make a quick decision on whether this is a signal of relevance, should I respond or not? And that filtering system is based on a chemical parvalbumin that forms actually during the initial critical period by the age 0 to 18 months. And that doesn't form properly. And so what happens is every signal they respond to, and that's what makes them, the autistic children are not able to cope with overstimulation. So even in the same thing in the society, when the society is on an edge, every little thing we become, we start assigning conspiracy theories and we become edgy. Like we were discussing, Jason and I this morning, the bridge collapse. Now, is this really a random incident, or is there a conspiracy? Is there a sabotage? So in these days, because there is so much happening, the first thought that comes to our mind is sabotage. That is the ADHD. Society has gone into an ADHD mode here because of lack of trust. I don't know whether I'm answering your question or I'm going in a tangent here.
Yeah, no, I appreciate where, in terms of trust and secure attached relationship, but I'm curious where cortisol figures in. So the stress response and then leading to inflammation long term.
Yeah. So if you are always jumpy, then there is too much cortisol released, and then the people end up with the diseases associated with that, high blood pressure, whatever, those kind of things. So what is important is to be able to, there is two parts to the signal processing. One part is differentiating and identifying what is of relevance. And then the other part is say what action should, how do I combine all these things to understand what is the meaning of this and how do I respond to it? And that balance has to be there, both at the individual level and at the society level. And when it is not there, that leads to disease.
Yeah. And I also want to just step back for 1 second. I really appreciate you brought a child lens of autism. My background is in kindergarten through 12th grade. English as a new language. And so part of my responsibility was to understand what was a language difference or a learning difference. And some of the students I worked with were diagnosed as autistic, but there was a very big continuum along that space of abilities and particular gifts that may not be rewarded or measured in a colonial assessment system that we have, that I think really serves the status quo and the way structures are codified into law. And I feel like this is the turn, this is this inflection point where we're starting to turn and look at this much bigger continuum, not only in gender, but also in abilities.
Yes, autism is actually a broad spread. It's a spectrum. And if they are very intense and they are able to assimilate a lot of things and be able to still make meaning out of it, they become geniuses, probably in a narrow domain.
Yeah.
Okay.
Yeah.
Yeah. So one key point that I want to make here is memory is actually a transient sequence. People think of the short-term memory as actually, it's really, we should call it short-term activity as opposed to short-term memory, because when this process is happening, when we are doing something now, it, it is an eternal now, and not if there is no past or future. The memory is a transient sequence. Well, I won't, it's a long discussion, I won't go there. Okay, I think hopefully this is the last but one slide. I already talked about the brain breaks the signals into different parts and chunking it. And okay.
Is there a way to put all of that on at the, okay. So I just wanted, it takes me a minute to see.
Yeah.
Okay, thank you.
Yeah, so this is the four parts that I was talking about. The four different things. This is the noradrenaline, this is the acetylcholine, this is the dopamine, and then eventually the serotonin comes and closes these things. So this is these sequences. So in terms of language, this then becomes like a phone, a sound, and then this becomes a phoneme. This is a syllable, and this is a word. And this actually in the computers, this is like bits and bytes and half words and full words. If you can see this same kind of chunking concept, concurrent processing is universal. That is really the point I'm trying to make. It's everything is natural evolution here. And this is happening inside our brain. And this is what I call as neuronal language. So this neuronal language happens in all animals. It's not just in human beings. This kind of breaking, these four chemicals, you can see it on a C. elegans, they're tiny worms. They contain the same four chemicals that we have. So this has been going on since time immemorial. And this language is really neuronal language, chunking it into things. That is how the evolution figured out how to remove the uncertainty and to be able to work at many different time scales. Okay. And the recognition of syllabus required for what becomes words and this. Okay. Yeah. I'm sorry. It's a whole big manuscript. I'm kind of going through a rush here. Okay. So the point here is everything is happening concurrently. So the brain is divided into multiple segments, and prefrontal cortex is working at a time scale of half a second. Hippocampus is working at a time scale of 1/6 of a second. And then the primary sensory and motor cortexes are working on a scale of 1/16th of a second. And then the thalamus, which is the gateway to the brain, is working at 40 hertz, 25 milliseconds, or 1/40th. Okay, so you can see brain is broken into parts. How do we understand this from a public administration system? I'm saying the public administration system is also divided into many different organizations. A small let's say from one teacher to a classroom to the principal and the groups together, or a department and the principal, or in a school system or in a government system, you can see different things are happening. And each group is doing their own activities within their own divisions normally, but periodically they must synchronize with each other at varied instances in order to accomplish common goals. So this is the concurrent operating architecture, whether you look at it from a brain or whether you look at it as an organization, it's the same idea. So recursive have similar building blocks here. So in essence, democracy as a governing system, the key word here is when it is comprised truly by the people, for the people, of the people, then leads to a governance style that resembles other naturally evolved systems. But the key word here is the governing system should consist of these people. They should be made of real people, and they should be they should be of the people, and they should be thinking about the needs of the people, and they should be representative selected by the people. So when you go back to the original sigmoid curve that I showed you, there is a quick response, and then there is a steady long-term response, and then finally bringing up all the stragglers into the change management. And in order to do those things, you need all of these three things. And this is what you see in the brain architecture and in any general open system developed by nature. It picks it off the constituents, okay, and it selects by learning the key people who need to respond fast and intermediate and longer timescales. And it is doing it not just out of curiosity, it is doing it for the benefit of the survival of the organism. So whether you look at it for the brain or whether you look at it as a total governing system, this system should be comprised truly by this thing. When that happens, you have a beautiful governing system. But what happens is many times people become corrupt. So the elected bodies can be corrupt. And then the whole system fails.
They just to be ignored.
Yes.
Jason, can you repeat that?
Pardon?
I missed what you said, Jason.
I said they just to be ignored.
Yeah,
well, so
right,
that is the problem.
Right. Well, this gets to the law again and the structures that were written, at least in
well, Remy said the memory becomes a public handbooks. That I like that. Right. I'm just holding exactly 20 pages of a checklist to do a drainage design report. And we are not forced on to do that. It's very big headache for us. But this is very interesting, but we gave you almost all the time. There's no more time left for the cases, etc. So I guess if you guys are interested to do a following session to do that.
I'll just leave it with a little joke here.
Good.
Serious thing. My favorite book is Harry Potter. In the last section here, this is a very interesting discussion. It says, "Tell me one last thing," said Harry. "Is this real or is this been happening inside my head?" Dumbledore beamed at him and his voice sounded loud and strong. "Of course it's happening inside your head, Harry. But why on earth should that not mean it's not real?" What
does that mean, not real?
What I mean by that is, if you think of government as the equivalent of the mind, the government must win the trust of the people when whatever is happening in the government is real and it is going to influence you. Okay.
Thank you very much.
Thank you.
You took almost a long discussion. So what do you say, Lisa? Do we do not have time to do the case?
Yeah. Right. But I do want to just frame for Jerry and Lucio and Gerard, who came later. What is the lab at MIT in which you work?
The department is called Brain and Cognitive Science. It's course 9. It's just like the electrical engineering and physics and chemistry department. There is a department called Brain and Cognitive Science. Within that, it is broken into a lot of different groups. One of them is called Simon Center for Social Brain. Essentially, the funding comes from Simon Center, and we're focusing on societal needs and how does the individual brain contribute towards the society. And that is what you can see I'm trying to focus on here. Understanding the brain and then enlarging it into a social concept.
I think your work is a big step beyond the Stanford Beer. I think VSM is kind of too mechanical there, but you take into consideration a lot of new elements. But Lisa and myself are trying to add more.
Yeah, no.
Go ahead, Ram. I
think we to do the case discussion, we should have the other presenters too, right?
Well, yeah, because I think I'm Robin's book. I held it up before. I just picked it up. Robin Aspie's book. He does this really nice job of framing inviting the land and the natural world. It's a very poetic treatment of the viable systems model and his experience with it. And he is spent time as an educator, which I think is an important frame that we consider of how we consider. You mentioned before about teachers and students, and I would say, I'm actually involved with a nonprofit, and we have a relationship with a lab at MIT that used to be the Media Center. Now it's called something about civil dialogue. And I would tell you that students want to believe that their teachers have power in schools. Things have changed so much that, and can say more about that, but the teachers that are left are teachers that want to be in relationship with students. But teaching has always been an art and complex. And so we've made it harder. And COVID was a push toward more technology. And it's very complex. And again, I'll say it's not adapting all that well for the well-being of a child lens, which is the one that I hold.
Thanks.
I appreciate your work very much. Very much. It's
Lucille, Jerry, Gail, Gerard, you are late here, but you have any comments, questions?
Yeah, I would just ask a question. I was on another Zoom conference, and so I was unable to be in two places at once. So the entire presentation thus far has been recorded, and so it's all about the concurrency of mind and matter.
It's being recorded. It's another presentation of our previous session that we had 3 presentation there.
Yeah, I was at the earlier one. Yes. Okay. Thank you.
Yeah.
I look forward to watching the video.
Thank you.
Wait about 1 week.
Jason, you're welcome to share the slides with people.
Yes, I will do that for the whole group.
Yeah.
Lucille.
Oh, hello everybody. By the way, sorry, I joined the group only at 5 because I had another meeting. And by the way, it was written 5 in your email, but actually, I guess it started 4, the group. So, okay, anyway, this is something that must be clarified for the future. Because you said you wrote wrong time, 5 o'clock, but I connected at 5.
Maybe it's because the summertime change.
Yeah, maybe, but it's still to be done. The summer time, the different legal time, but not yet entered in working. So it will be right in the future, but not now at the moment. Anyway, this maybe can be just check it for the future meetings. It's going to change actually and anticipate, and it will be fine, but at the moment it's not. Anyway, in the matter, so as for what I heard, my comment is that as usually there is a big difference between the world of biology and the world of society, let's say, or social communication, because when you are dealing with biological objects in very broad sense, biological phenomena, I mean, the media are chemical media, electricity, mechanics. No, you have these three media, three ways to interact. When you are dealing with social phenomena, the medium is communication, is words, is language. And this changed things very much, very, very much. It's one big difference. I mean, ontological differences. And you know, in the history of those, there has been so many times, you know, making the analogies between the field of biology and the field of society or economy, but they actually work very, very bad. And sorry, the second point is that, you know, the parts of the whole in society and in economy, fortunately or unfortunately, have a very peculiar property that they like power very much. So the question is not what we should do for the others or what should be the role, but they are seeking for power. And so the behavior, this type of goal is changing the behavior very much from what you can design or what you can do. So it makes another big difference.
Yeah, and I covered both of those in the talk. If you get a chance, please look at the video. But in terms of biology, I tried to explain the concept of neuronal languages. The alphabet, the chunking of the signal happens in the neurons, and those time scales are essentially the same time scales that have now become spoken language in terms of syllables and words, and even how we form the sentences, how we form the phrases and sentences follow the same logic as how biology works. So when you get a chance, please look through these slides and then we can discuss more. So the evolution, the communication or the symbolic language that the human beings develop is based on neuronal language. And I define language in a general sense that language is a medium of expression. And when we talk about, when I think of walking, I think of walking as a language. It is like a motor skill, motor procedure that is expressed. Swimming is, we can think of it as an expression of certain activities. So you have to think about language in a general sense. It is as a mode of expression. Okay, when you see it that way, then you can see very easily what happens at the neuronal scale is the same thing that is progressing towards spoken language. So please look through that. And then the second question that he asked is, some people are making, let's say greed is the motivator. But what is important is initial change when you want to do, you cannot have all million people voting on every little law that we want to pass. You need to have a select body. So but if you waste too much power with that body, then it becomes a winner takes all. And this is what Grossberg explains in his sigmoidal distribution that I covered in an earlier slide. You cannot empower that early decision makers so much that becomes totalitarian or authoritarian system. You need to have some people with authority, but they should have responsibility and there should be a controlling body over them. And that is the central linear portion of the sigmoid. That is the so-called democratic, let us say Congress overriding the White House, that kind of things. So that's the Grossberg model. Please look through that sigmoidal curve discussion. Okay. I answered both of your questions.
Yeah, there's also an assumption. Sorry, 1 second, Sherrod. There's also an assumption here I think we need to sort of uncover is access to the voices to be heard. So who is invited into the arenas for voicing their experience. So if we were talking about the garden plot, community gardening project that I was going to ask, my question would be, you know, if we want to have bottom up and top down access. I don't exactly see that in most democratic arenas now. Like for the people who are first degree affected by the structures and processes involved in terms of institutional poverty, generational poverty, lack of access to clean land, or, you know, I mean, the historical setup sort of. There's something about like at what stage, like I wouldn't invite folks to a discussion like this necessarily, but at what stage in the process can we invite people who are directly affected? So I'm looking at really allowing, or, you know, not suggesting how they should be led. I think there's a little bit of an assumption of a top-down here rather than truly leadership from the people who are directly affected. So just like checking our assumptions, I think is an important.
Yes, good point.
Rob?
Okay.
Thank you. At the moment, I'm reading something that is difficult because there are so many concepts in it that are also in other frameworks. I'm reading something about unconscious cognition, and I have the same problem. It's interesting to see that this author is using many similar concepts as Ram is using, but the meaning is entirely different dependent on the context and the frame, etc. And I have a strong rejection towards the word trust. I think trust is patronage. It's completely misused. I wouldn't trust any psychotherapist who claims that I have to trust him or her, etc. So I am in a world where I am confused by the too numerous meanings of the words. So unfortunately, I cannot help you.
Gail, are you there?
Yeah, what? I'm sorry?
I was trying to invite Gail to talk. Go ahead, please. Gail?
Well, she's here. I think she's in listening mode, which is actually, you know, what I've learned in previous peace studies courses. I've learned that the listening is actually the biggest point of power, because when responding, you know, we have an agenda or a goal. So I think I'm going to invite her to, if that's where she wants to be, is to stay there. And again, I think we may be intersecting in the, you know, the beauty of having very different heritage experiences and bodies of knowledge in a somatic way of the wisdom and the listening. Yeah. So I mentioned that my background is in second language acquisition, and so I recognized when I was explaining this a very good assessment tool that was developed for language proficiency in content and basic interpersonal communication skills in academic settings, K-12. But, you know, there's like 4 modes back to communication of listening, speaking, reading, and writing, and it's always in a content space. But that also sort of ignores that same cultural heritage. You know, my job was to sort of look at the knowledge and concepts exam for the linguistic load and see if it really matched the students at level 2 proficiency who the state said they should be tested. And interestingly, it was in math. So somehow there was an assumption that there wasn't all that much language in the language of math, which I would argue is not quite true. But that listening and reading are bringing in information, and speaking and writing is putting out information. And that's what I think is important. My experience in those meetings at the Department of Public Instruction was because I had so much passion, I couldn't be heard. There wasn't a trust. There was something like, why is this white lady so angry at us? and I'm really trying to, that was a dozen years ago. And I found that I wasn't invited back to future meetings. So I'm still at this point of really speaking to the essence, and also communicating how trans-contextual we all are, and how mutual learning spaces do involve the very thing Gerard has mentioned. We can't assume, the speed at which trust happens. And like in the project that I'm only an observer and just starting to begin, like curious if I can bring this youth-led ethnographic qualitative research and systems awareness to a space outside the structures of school, because kids are still in school when they have these conversations, interviewing teachers, interviewing peers, asking questions. That the first set of questions this lab gave them, the kids said, oh, we don't talk this way. We don't use that. And so the kids rewrote the questions, which was of great value to the lab. So anyway, it's this very iterative process of who we can be with each other. And that happens at a very slow pace, especially when there are all these histories that we don't really know about each other. And your work is really important, and I really appreciate the thoughtfulness and the careful thought that you've obviously done.
Are you guys willing to come back for another session to analyze the cases? Lisa have one case, I have one case, and Rem, your framework will be needed, and perhaps we'll confirm to get Robin in as well.
Okay. Yeah, sure.
If you want to do that, when? Which Wednesday is convenient for all of us? Lisa, which Wednesday?
Oh, man.
Maybe sometime in April 17th?
I can do that.
Yeah.
No, that one's not so great for me.
And then when? We already occupy, the next week of 17 is, 24 is already booked.
Oh, you're already booked. Okay.
Yeah.
Well,
So you cannot do 10, right? Too fast. Or you can do 10.
either one. I'm going to have to miss something, and like
Make a pick. Which
yeah.
one?
Well, there's two other things. I'm good at hearing two different conversations at once, but three is a little much. So you just pick, and I will I'll be here.
10?
Yeah, sure. I mean, if I think we should check with Robin.
April 10? Yeah, we can email him. And the RAM 10 is good for you, right?
Yeah, both 10th or 17th are good.
10 to what?
Either 10 or 17, either one, I'm okay with both.
Oh, otherwise, okay. Okay, Lucille.
Yeah.
It's okay for me.
Okay. So let's shoot for 10. April 10. We will continue today's analysis.
Okay.
Okay,
I
good.
have a meeting at 5.
What?
I have a meeting at 5, so I can only be here from 4 to 5. Well, in London time.
Okay, so we will figure out how, but I will double check the time zone differences, and
Yeah.
I will send a more clear the reminder.
Okay.
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 Okay, thank you very much, guys.
Thank you.
And
Thank you.
it's
Thanks,
very
Jason. Thanks
interesting.
for the opportunity. It was a good discussion. Thank you.
Yeah, you're doing great. Thank you very much.
Thank you. Thank you.
Yeah.
Bye.